Here in this video, we are solving a previous examination question, IIPMT 2015 from units and dimensions. The problem is like this. If energy, velocity and time are chosen as fundamental quantities, how does surface tension can be expressed in that format? So that's a simple and beautiful question. It depends on a concept called principle of homogeneity in units and dimensions, which tells you that the dimensions of fundamental quantities in any physical equation on both left hand side and right hand side are same. Having said that, it is given that now the surface tension, I'm calling it like S, he is saying surface tension depends on energy. By how much dimensions, I don't know. So I'm calling it like power of unknown dimension X, velocity power of unknown dimension Y, time power of unknown dimension Z. So he's asking us to find the values of that X, Y and Z. So I shall write the dimensional formulas of each term of this equation, right? Surface tension. So first of all, we shall remember back what's the definition of surface tension. This is the force acting on the surface of the wire on an imaginary tangential line per unit length. So the dimensional formula of that is force is MA ml t power minus 2 by length is L. So the dimension formula of surface tension is m power 1 L power 0 t power minus 2. Similarly, let us write for energy. We can take any energy like potential energy, kinetic energy. For simplicity, I am taking kinetic energy. Half is a number which won't have any dimensions. Mass has a dimension of capital M. Velocity is rate of change of displacement Lt power minus 1 whole square. So the dimensions of energy is ml square t power minus 2. Of course, dimension of velocity is rate of change of displacement Lt power minus 1. Dimension of time is time itself. Now, knowing all the fundamental quantities terms in terms of this given equation, let us substitute all of them in the above equation. I can eliminate the proportionality and write a constant k, t power of x, energy power of x, velocity power y, time power of z. I need not worry about this k. I can write it as a 1 because we are not actually calculating a physics relation, rather we are only expressing it in terms of dimensions where proportionality constants have no physical significance. Let us substitute all these values in this equation and see what happens. Yeah, in this equation, surface tension is m power 1 L power 0 t power minus 2 can be expressed as energy power of x. So what is energy? M L square t power minus 2, as I have already explained, whole power of x. Velocity Lt power minus 1 whole power of y, t time power of z. Let us rearrange the terms in such a way that let us write all mass dimensions at one place. Here m power 1 and x is there, so m power x. Here there is no m. So m has the dimensions of x on right hand side. Length has the dimensions of 2 and x. 2x. Here it has a dimension of y. Here no dimensions of length. Time has a dimensions in the first term as minus 2x. Here minus y. Here plus z. That's on right hand side. Left hand side, anyway, we know the dimensions of that m power 1, L power 0, t power of minus 2. As I told you, as per principle of homogeneity, when a physics equation is correct, the dimensions of fundamental quantities on left hand side and right hand side shall be equal. So I can equate the dimensions of mass, equating dimensions of mass, here 1, here x. It implies I got x equal to 1. So I got already one value x. Now equate the dimensions of length. Equating dimensions of length on both sides. Here right hand side 2x plus y. Left hand side it is 0. But we have already proved that x equal to 1. So 2 plus y equal to 0. That implies y equal to minus 2. I got the dimensions of y. Now I need the dimensions of time, right? Then equating dimensions of time on right hand side, this is the power minus 2x minus y plus z, on left hand side minus 2. Let us substitute the values. X value have found it as 1 minus y value we have found it as minus 2 plus z equal to minus 2. So minus 2 plus 2 plus z equal to minus 2. So this is 0. So z equal to minus 2. Now I got the dimensions of all of them, x, y and z. Let us substitute them in this relation, that what is given for you. It is said that surface tension depends on some constant into energy of unknown power x. But we have found that x value is already 1. Velocity unknown power y as we have taken. But we got that y equal to minus 2. Time of unknown power z. But we found that z is also minus 2. So the relation of surface tension, expression of surface tension in terms of energy, velocity and time power in such a way that energy power 1, velocity power minus 2, time power minus 2. Look at the options. Where is that kind of answers are there? Energy power minus 2, energy power 1 is there in this and in this. Velocity power minus 2 is only in these two. So this is ruled out and this is ruled out. But time power minus 2 has to be there in option A. There is time power minus 1, which is obviously wrong. So time power minus 2 is also there in option C. So option C is the correct answer to solve this problem. So remember that to solve this problem, we use the principle called principle of homogeneity, which tells you that an equation is a homogeneous equation in physics. What is that homogeneous means? Dimensions of fundamental physical quantities on both left hand side and right hand side are equal. That's the principle of homogeneity. That's why we have equated the dimensions of mass, length and time on both sides of the equation. That's it for now. Thank you for watching.